Welcome to Science Olympiad Session 3. In the first two sessions, we covered how do we calculate power, energy, and voltage drop across a single resistor and across two separate resistors. We are going to take this example a little bit further, and in this example, we'll do a quick review of voltage drops across resistors, and then we will spend the next session working on parallel resistor circuits. Okay, so similar to what we did before, we're going to draw a simple circuit. So we have a positive side and a negative side to the battery. We're going to draw three resistors now. And our goal here is, let's put some voltages here. We're going to do our famous 10 volt circuit. We'll do 2 ohms. We'll do 3 ohms. And we will do 5 ohms. Okay, so those are the values of our 3 resistors. Okay, so the questions are going to be very similar to what we did last time. Is we need to find the current in the circuit. We need to find the voltage drop across the 2 ohm resistor. We will calculate the voltage drop across a 3 ohm resistor, and we will calculate the voltage drop across the 5 ohm resistor. And last but not least, we want to compute the power that is being generated by the 5 ohm resistor. Okay, so those are our 5 different questions that we need to solve. Okay, so I think the first thing we need to do is now figure out what the current is. So let's start with the current. So with the current, we know that we're going to use Ohm's law, which states V is equal to IR, current times resistance. We know that the voltage is 10 volts in the circuit. Okay, for this entire circuit, we do not know the current. And when it comes to the resistance, we need to figure out whether these 3 resistors are in parallel or are they in series. If you look at each of these resistances, they are all in series. Okay, the way we can find out a resistor is in series if there is no division between the 2 resistors. Okay, this line right here feeds from one resistor to another, but if the resistance looks something like this, we know for a fact that this is no longer a series resistance. Correct, right? So this is just a quick way for you to figure out whether the resistors are in series or they're not in series. Okay, now let's go back again to our computation. Since we know these resistors are in series, we know the total resistance on the circuit is simply 2 ohms plus 3 ohms plus 5 ohms, okay, which makes it 10 ohms. So we have 10 volts equals to current times 10 ohms, which leaves the current is equal to 1 amp or ampere. Okay, so at this point in time, I hope that you are all comfortable with coming up with the calculations for the current. Okay, so we're going to erase this the best we can, and our next step here would be to compute the value of the voltage drop. Okay, now as we learned before, the value of whenever we say a voltage drop, we mean what happens in this particular example, what happens if we were to take a voltmeter across a 2 ohm resistor. That's what the voltage drop essentially signifies. Okay, so if we put a voltmeter across the 2 ohm resistor, we know we can again, in order to compute that voltage, we again use Ohm's law, which says voltage is equal to current times the resistance. In this case, we know the current that's going through the entire circuit is 1 amperes. Sorry, I made a little mistake here, but is 1 amp. Okay, so we know the current that's going across the entire circuit here is 1 amp. Therefore, the current is 1. The resistance that the voltmeter is measuring across is for 2 ohms, and therefore the voltage drop across the 2 ohm resistor is simply 3 volts.
You mean 2 volts?
2 volts, sorry. So I have a unique visitor here with me, and he's helping me identify the problems. And he said it's 2 volts. So he's correct. It is 2 volts. Okay. Okay. Sorry, I had to disconnect here, but I'm back here online. So again, this was a mistake here. It is equal to 2 volts. Okay. All right. So we've done with that part. Now let's erase this, and then we can go and find what the voltage drop is for the second part. Okay. So now our next part is what happens if we go and measure our voltage drop across the 3 ohm resistor. Okay, so we'll put a voltmeter here. Okay, and in this one example, we know the current is still the same. It's 1 ampere times the resistance of 3, which leads to 3 volts. Okay, so we know that across the 3 ohm resistor, we have a voltage drop of 3 volts. Similarly, we're going to do a voltage drop across the 5 ohm resistor. In this case, we still have the same exact current, which is 1 ampere, but the resistance is 5, so the voltage drop is 5 volts. Okay, now the next question really comes down to is how do we compute the power? Okay, for the 5 ohm resistor. Okay, now if you guys remember from earlier, what is the formula for power? Power is equal to voltage times the current. In this example of the 5 ohm resistor here, the 5 ohm resistor has a voltage drop of 5 volts. And the current that's flowing through it is 1 ampere. So the power that's being dissipated by the 5 ohm resistor is simply 5 watts. Okay, so I hope this has been helpful. Again, the idea is any point in time we use a voltage drop. It's generally simply means that you are trying to make a measurement in terms of how much voltage is across that resistor. This is it for Circuit Lab session 3. Thank you for joining.